SICK is well known for its wide range of photoeyes that include diffuse, retroreflective, and through-beam sensors, all built to handle many industrial detection tasks. With durable designs, IO-link support, and enhanced sensing capabilities tailored for specific needs, SICK sensors are among the most reliable and flexible in the market. But one lesser-known part of SICK's lineup is its fiber optic sensors. While often overlooked, these sensors are key in situations where standard photoeyes just don't cut it. It's a go-to if you have space limitations, harsh environmental conditions, or the need for incredibly precise detection. And at the core of Six Fiber Optic line, it's a WLL80 Fiber Optic Amplifier. How y'all doing? My name's John Lim, product specialist here at EandM, here to remind y'all of Six incredibly powerful WLL80 Fiber Optic Amplifier alongside its robust line of sensor heads. So here's a WLL80, a compact amplifier with DIN rail mounting that can use both through beam and proximity fiber optic heads. It was built for high speed, high precision tasks and boasts a sweet set of features. You get response time as low as 16 microseconds and sensing ranges of up to 20 meters depending on which sensor head you're using. There are also other sensor head models that could detect objects as small as 0.02 millimeters in diameter. It offers dynamic teaching capabilities alongside adjustable sensitivity and threshold settings. It also has this nice OLED screen for on-device configuration right over here, and you can optionally configure it remotely. That includes diagnostic capabilities as you configure it through SOPAS ET. And while they're available as standalone units like this guy, they're also available as modular bus configurations for easy commissioning and more manageable cabling. When would we choose fiber optic sensors like the WLL80 compared to the rest of Six sensor lineup? 1. If we're dealing with real tight and hard to reach spaces, fiber optic heads can be just a few millimeters in size. They fit into very small or awkward locations, while the amplifier can be mounted somewhere else more accessible. 2. We have glass fiber cables and sensor heads rated for down to negative 60 degrees Celsius up to 300 degrees Celsius. They're built for such an extreme temperature range, and they can also be very resistant to chemicals. It makes them perfect for places like industrial ovens, sterilizers, and corrosive areas where standard photoeyes would just fail. 3. Thanks to the quick response time and small light spots, fiber optics are great to look at incredibly tiny or fast-moving parts. It is especially useful for applications in semiconductor factories, small electronics manufacturers, or pharmaceutical laboratories. And 4, with a sensing head having no electronics at all, fiber systems can work in a vacuum or in areas with strong electromagnetic interference, where regular sensors just can't do that. So when looking at your application, don't forget to consider a fiber optic sensor. It may give you the edge you need compared to standard photoeyes. Now let's take a look at how quick it is to configure the WLL80, both on the sensor and on 6 free SOPAS ET software. All right, so I have a WLL80 sensor right here. It is actually mounted from the back of it with this small little uh, mounting bracket that could be then screwed onto some DIN rail, as you can see right there, which is pretty neat. And then when you first turn this on right from the factory, the first thing it'll ask you is what kind of language you want to speak with it. So if you open up this cover right here you'll have some buttons to work with. You have a plus button, a minus button, a OK/menu button, and an escape/teach button. So you'll use the plus and minus button to interface with what's going on the OLED screen right here. So let's go ahead and decide which kind of language you want to do. You can decide German alongside Chinese, Japanese, and Korean, but we'll stick with English for now. The next thing it'll ask you is what kind of output function you need for the sensor to operate with, so either push-pull, PNP, or NPN. And last but not least, it'll ask you what kind of sensor do you need it to operate as. So if you need it to be a prox sensor, these two cables will then operate more so as both the sender and the receiver. And then with the through beam, then you'll have one cable be the sender and one cable be the receiver. Right now I have this set up as a through beam sensor, so let's go ahead and do that. Hit OK. So right now it's outputting what it's called a energy value. It's just, It's just the perceived light that's being received from from the receiver, or from the sender to the receiver. Sorry about that. And as you can see, if we try and put something in front of this sender receiver, that energy value is going to change. So right here, I have a white ferry ticket that I have, and that energy output changed. But right now, we have our output set as an energy value of 100. So then, if we have a more opaque, blacker object pass through the through beam sensors, the sensor heads like this black card right here, as you can see, now we're getting a energy value of under 10, which is under 100, and now the sensor is sending out an output. If you want to change that, that's incredibly easy right here on the sensor. You can just ask to teach a new set point or new threshold value. Let's do a single point teach. We'll do a 10% error. Let's go ahead and set that, and we'll put this my white little ticket right here and hit OK. Let's hit update. And now it's running with that new set point. So if we go back to that black card, as you can see, switch it right there. I'll still send an output function, but now if we go with my white card, we've set it up now where it can also send an output function when the sensor head sees this white card through its sender and receiver. And now that's a really quick way of how to teach something here on the sensor. As you can see, if you go to the menu, there's a variety of options for you to configure this however you want. You can, switch back whatever detection mode you need, switch back the inverter outputs. You can change the response time of the system, go back to change the language. You can change the display and a variety of things. Add on an on-off delay. The possibilities are endless here. So that's one of the ways that you can set up this sensor just on the sensor itself. But if we can look at it through 6 free SOPAS ET software, we can also showcase you how not only can you still configure the sensor, you can also go deeper and look at some further diagnostics of the sensor as well. So we'll get to that. All right, so now we are on SOPAS ET. This is 6 free software available for everybody to download to help configure any of their smart enhanced sensors right here. And as you can see here, I have a WLL80P already connected. It's the same WLL80 that I just showed you guys. So let's go ahead and double click on this and showcase what else you can do while you're configuring this through SOPAS ET. So right here you have your home page showcases, what's going on the display page, a graph on it's currently looking. So I'm going to go ahead and kind of have something pass through the sensor again. As you can see now, it's changing its receiver level, as you can see right here, and it is sending out an output. So you have that. You can go ahead and change, you can put any specific application tags or even put in a name for the sensor right here as well. So that's one thing. And you can also get all the information or documentation for the WLL80 right on this as well. The general device settings, and that this is where we can configure some basic things like, how you'd like to get pin 2 to be set, how you'd like to change the brightness of the display, then the inverter external input, how you want the indicator to show, whether it be digits, a percentage, or even a bar graph, change the language like we just showcased, do a factory reset, things of that nature. And this is still all settings that you can do on the sensor itself. Enhanced sensing is where we do most of our teach-in and threshold level switching right here. This is where you can change whether it's a through beam or proximity. This is the top value that we had for our switch point. And then you can go ahead and change a variety of different settings right here as well, like response time, the intensity of the sender, and also things like auto adapting. So this is all available right here. And as you can see, as I put something through my through beam system, it's seeing that. Now, what is unavailable on the sensor but is available here is this diagnostics tab, and this helps showcase some information what's going on with the sensor. How many hours has this sensor been operating, the current temperature, and then you can use this to help send out signals of what kind of upper temperature threshold or lower temperature threshold it can work with, and it'll also have any errors or events that might have happened here in its history. And then here in Smart Task, that's just how you can switch in any timer delays, any logics, or invert logic of certain systems, things like that. And that's how you can also configure the WLL80 here on SOPAS as well. And there you have it. This is the WLL80, and this is how you can configure either through the sensor or through SOPAS ET. And next, we should definitely look at the kind of sensor heads that are available on the WLL80. All right, and our fiber optics amplifier would not be complete without its set of fiber optic heads. Like I said, we have a variety of fiber optic heads available, and we're here to showcase them to you. So our most basic set of fiber optic heads would be our threaded sleeve and our smooth sleeve fiber optic heads. We have them available with M6 threads on them, really great for easy mounting, but we also have them as smooth heads as well if required, and you just secure it with a set screw. We also offer sensor heads that have 90-degree deflection on them in case you need that angle. And we also have one that offers a flat design as well. So those are much easier to mount, and if you have much tighter spaces they need to operate with. We also offer long end sleeves where they're threaded at the end, but then they have much smaller sleeves all the right over there. Really great for very tight spaces and for really reliable detection for small objects. And finally, we have these area detection sensor heads that are really great to create a laser array, so you could detect things like sheets, compare height differences, things of that nature. So those are when it comes to basic sensor heads, and it's more of a variety of the type of head it is. We do also offer sensor heads that are heat resistant. They can go up to 300 or even 350 degrees C. We also have them that are oil and chemical resistant, so that's incredibly great as well. And for more industry specific ones, we do have liquid level sensor heads as well, really great for detecting liquids. And we also have V optics sensor heads that are really good for things like LCDs, transparent objects, and semiconductors. So we have a variety of sensor heads available alongside the WLL80, and that's what makes it incredibly versatile, incredibly powerful piece of equipment. So if you have any questions about these, feel free to contact EandM, and we'll be happy to connect you with a local product specialist to see if fiber optics is the right application for you.